Welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And again, in this video, just like example 1, we want to express vector PQ in column as a column vector. And again, what we need to do is note the x-axis displacement or the horizontal displacement and the vertical displacement, and note the direction. You can already see to move from P to Q, you must cover 6 steps along the x-axis and 3 steps downwards along the y-axis. So note that the downwards direction along the y-axis is negative. So vector PQ, so to speak, vector PQ is 6, -3 as a column vector. 6 steps along the x-axis and -3 steps along the y-axis. But the negative here is used to signify that we are going down. We are not going up, we are going down as the way the arrow is showing. That is part A. And then part B, find the magnitude of the vector PQ, the magnitude, or rather the size of the vector PQ. And just like we have done in example 1, we now need to employ the Pythagoras theorem when we say PQ, as we know, this is 6x, or rather 6 squared plus minus 3 squared, and then the square root. So the root of 6 squared plus -3 squared. Note that anytime we square a negative number, it becomes a positive, so there is no problem with that. So this is the square root of 36 plus 9, which is basically the square root of 45. And the square root of 45, if we may get that from a calculator, the root of 45 is basically 3 root 5, but to 2 decimal places 6.71 to 2 decimal places. This is equals to 6.71 units. We don't talk about centimeters here or meters, just unit. This is to 3 significant figures or to 2 decimal place. Part C of the same vector, we are the same question rather. Calculate the size of angle y. Calculate the size of angle y. And again, according to the position of y, we have been given the opposite side and the adjacent side, because this is at the hypotenuse. We cannot use the hypotenuse because we are the ones who have calculated it ourselves. Yes, we are right, but assuming we were wrong, then we would now transfer that mistake to part C. So it is always advisable to use the values and details that are already provided in the question and avoid what you have calculated yourself. Incidentally, here we have opposite side and the adjacent. That means we can again use the tangent of y is opposite, which is 3, all over adjacent and 6. Let me say something here. We know, as we talked about answering part A of the question, we said the column vector is 6 minus 3. Minus 3 does not talk so much about the size of, or the size of the steps. It talks everything about the direction of the displacement or the steps. It means we had to walk 3 steps down. 3 steps down, not up, along the y-axis. So it doesn't matter whether we are going up or down, we have 3 steps. So the size of that line is 3. That is why we don't transport -3 here. We just talk about 3 steps along the 6x. Please note that very carefully. You should avoid that mistake. And therefore, this is just a half, and therefore y is going to be the tangent inverse of a half. The tan inverse of a half, shift tan of a half. Let us see what this gives us in degree form, 26.6 degrees to 1 decimal place, and therefore y is 26.6 degrees to 1 decimal place. And that is just how we answer that question. Thank you, and let us meet in the next video.